All right, welcome to Notes on Rotations. So this is going to be our second of the two isometric transformations. This is going to be rotations, and rotation is a turns about a fixed point. So basically I'm going to take a figure and I'm going to rotate it around a fixed point. You can see that in these examples right here. Here's my origin right here. And if I rotate point B, I'm rotating it around on a fixed point and I'm sliding right over here. In the same regard, I'm taking point A and I'm rotating it around here. And then this one, point C, is rotating. And all of these are rotating about the point of the origin, which is located right there. So this is what we're going to talk about today, is the rotations or turns about the fixed point or the origin. And what we're doing today only works with rotating around the origin. Okay, so the next part of this is, what are rotations? Well, they are isometric. And what makes them isometric is that the image does not change size or shape. So the image is not going to change size or shape, okay? And then how do we denote a rotation? Well, we saw yesterday in our notes that a reflection is a small r. Today, rotations are going to use a capital R. So when we look at rotations, we're going to use a capital R. And so if I'm going to use the rotation notation, I'm going to write this nice and red for you. Rotation notation is going to be a capital R. It's going to be what my rotation is. So let's say if it's 90 degrees and I'm talking about triangle ABC. So I'm going to do triangle A, B, and C. And when I rotate it around that 90-degree angle, I'm going to get triangle A prime, B prime, and C prime. Okay? So the big difference between reflections is I have a small r, rotations I have the capital R. All right, moving to the next page. If you need to pause and take a look at it and get everything down, please do so. All right, rotation direction. One full rotation is 360 degrees. That makes sense because this circle has 360 degrees. A straight line is 180. So one full rotation would be 360 degrees. This would return all points in a plane to the original location. Counterclockwise is a positive, and I'm going to use the word positive direction, and clockwise is a negative direction. Negative direction. Change colors here. And so if I'm going to rotate positively, I'm going to go counterclockwise, and if I'm going to rotate negatively, I'm going to go in a 90-degree angle. And as we do this, we want to think of quadrants. And you think back to Algebra 1, I want you to think about quadrants, and that's quadrants on a coordinate graph. And remember, quadrant 1 is always going to be here, quadrant 2 is here, 3, and 4. So we're rotating through the quadrants. All right, a 60-degree rotation is the same as we'll use as a negative 300 degrees. So a 60-degree rotation positively would be the same as going backwards negative 300 degrees. Coterminal angles can be calculated using the formula. A coterminal angle equals initial angle plus 360n, where n is an integer. And you're thinking to yourself, what is n? Well, n can be anything. N can be, let's say it can be plus or minus 1, or plus or minus 2, plus or minus 3, and so on and so on and so on. You can pick any random number. For n, it's just an integer, okay? Just an integer. So I want you to think about what this formula is, which is we'll use blue, coterminal angle equals initial angle plus 360. How would I say that in your own words? You can pause the video right now and try to write it and see if you write the same thing I do. Okay? All right. See if you got the same thing I get. So I'm going to say new angle. New angle is equal to the angle that I choose plus 360 times n. So new angle equals angle plus 360 times n. Okay, and this new angle I'm using for the word coterminal angle. So really that new angle is my coterminal angle. Okay, that's what I mean by new angle, what I'm creating. All right, hopefully you got what I got. If not, go ahead and pause right now. Make sure you have everything that I've written. As you take notes, remember, what I write, you write. All right, moving to the next page. So what are two positive coterminal angles and two negative coterminal angles to 60 degrees? So to 60 degrees. Well, let's think about this. I need a total of 4 because it says what are two positive coterminal and two negative coterminal. All right, so two positives, and it's to the 60 degrees. So I want my coterminal angle, so I'm going to label that CTA right now. And that's going to be equal to, my original angle is 60 plus, what do I have to multiply by? You're right, 360. And I can pick any positive number I want. Well, I'm going to start with the nice easiest one, and that is 1. So if I do my math and I look at the calculator and I plug in 60 plus 360 times 1, what do I get? Well, I get 420 degrees. If I do the same thing, but this time I'm going to do it for another one. So I need two positive numbers, plus 360. Well, I used 1 last time. Why don't I try 2? Well, now in the calculator, 360 times 2 plus 60. Well, what is that going to give me? Well, in the calculator, that's going to tell me that's 780 degrees. Okay, so that's for two positives. Now let's do the negatives. So I'm going to do the negatives in red so you can see the difference. I'm going to do negative in red. So my coterminal angle for negative, same idea, still 60 degrees. What I'm looking at, 360. This time I'm going to do a negative 1. So it's negative 360 plus 60 gives me a negative 300 degrees. The second negative one, CTA, 60 plus 360 times. I did the two up there for the positive, so I'm going to go ahead and stick with that theme. I'm going to do negative 2. Well, 360 times negative 2. Go ahead and put that into your calculator right now. See what it comes up with. I come up with a negative 720. Add 60 to that, and that gives me a negative 660 degrees. You can check and double check your math. Make sure my math is correct. As I look at it, 60 plus 360 times negative 2 is a negative 660. If you're not understanding, remember, just look right above. A coterminal angle is equal to an angle. I chose 60 because that's what the problem told me. And then I have to multiply it by 360 times whatever I want to multiply by. Any integer. Well, I chose 1 and 2 because they're the simplest to choose. And I did it for both the positive coterminal and two negative coterminal angles. Any questions, just feel free to ask. Pause, make sure you get everything down, and we can go from here. All right, moving on. The next part, we're going to talk about the rules for rotation on the coordinate grid. Now, I need to remind you that this is only going to work about the origin. So I'm going to underline it right here because it only works about the origin, which means I need to rotate about their origin, okay? And so I look at this and it says rotation of 90 degrees about the origin. I have a pre-image, I have an image, I have a box. Well, this box pretty much tells me that I need to go ahead and plot the points. And as you can see on the graph over here, I have a graph that says, hey, C, X, Y. I rotate it over. I have a nice little graph for you to take a look at and see how it rotates. And it's rotating on a 90-degree angle because why? Because we asked it to be rotated on a 90-degree angle. So I'm going to go ahead and plot the points. A, my pre-image is at 1, 1. B is at 2, 4. And C is at 3, 2. So C is at 3, 2. If I look at my image, A is at negative 1, 1. B is at negative 4, 2. And C is at negative 2, 3. And just like we did with reflections, I'm going to ask you what changed. What changed? What was the difference? What changed? What changed with the X and Y from pre-image to image? Pre-image to image. Well, if I look at it, I got a 1, 1 in the pre-image for A. I end up with a negative 1, 1. Pre-image for point B, I have a 2, 4. I end up with a negative 4, 2. I kind of see a pattern here. And then for point C, I see 3, 2. And then all of a sudden, the image is at a negative 2, 3. Well, this really shows me that the rule is going to be, well, the change is that I'm going to put the Y term first, but put a negative with it, and then put my X term last. Now my graph actually shows me that. It showed me that up there, and I kind of wanted you to see that if I rotate about a 90 degrees of the origin, that my rule for the notation is going to be at a negative y, x. So as I'm going to write this, and if I was asked to write it, my rule for the notation is going to be r of 90 degrees of xy is equal to a negative y x. Now once again, I'm going to give you this when it comes to test time. I'm not going to ask you to memorize it. I want you to be able to apply it or know what it is, okay? So that is your rule for 90 degrees about the origin. If you need to pause to catch up, please pause, freeze it, catch up, so we can move on. All right, here we go. The next one is going to be a rotation about the origin, and this one is for a rotation of 180 degrees. So we're going to do 180 degrees, a reminder that it has to be about the origin by 180 degrees. I have my pre-image up here already. I have my image. I can see on my graph that it's rotating a straight line. As you'll notice, this dashed blue line is a straight line. Remember that the degrees of a straight line is 180 degrees, so we know that it's there. So let's go ahead and plot our points in our table. Point A is at 1, 1. Point B is at 2, 4. And point C is at 3, 2. My image is at, what is that? A negative 1, negative 1. B is at a negative 2, negative 4. And C is at negative 3, negative 2. And this is, of course, A prime, B prime, and C prime, or my image. And so, once again, what changed? That is my theme for you when when you're looking at this, what changed? That is the question you should be asking yourself. From x, y, what did it change to? What did it change to? Well, if I look at it, I see that I got a 1, 1, and then I have a -1, -1. Okay, so it looks like I just added a negative, but I'm not positive yet. Well, my pre-image point B is at 2, 4. My image is at a -2, -4. That's pretty good evidence to say that I'm just adding the negative. But let's check the third point. The third point's at 3, 2. It is a -3, -2. So my thought, my thesis, my hypothesis, my idea is that I'm just adding a negative when I'm going by 180 degrees. So this becomes a -x, -y. So my rule for the notation is going to be a capital R. 180 degrees, xy equals a -x, -y. And as a reminder, I'm not asking you to memorize that. I'm going to give it to you. You just have to be able to apply it. Apply it. All right, if you have questions on this, feel free to ask again. Happy to have it done for you. But if you need to catch up, once again, please pause and we will wait for you. All right, moving on. The last one, rotation of 270 degrees. Well, rotation of 270 degrees is 3/4 of the way around, but I also need you to know that this is also a rotation of -90 degrees, and you're going to see that a lot. That 270 degrees positive is going to be the same rotation as a -90 degrees. Okay, so positive 270 is the same as a -90. Okay, -90. And so if I'm looking at this and my C is translating this way and it's going around and around and around this way, that's a positive 270 degrees. Well, conversely, if it just went this way, which is clockwise, which is negative, it only went 90 degrees. It is the same rotation. Okay, so positive 270 is the same as a -90 degrees. All right, so let's go ahead and plot our points and see where we are. A is at 1, 1. We got a thing going with our points. B, 2, 4. And C is at 3, 2. My A prime is at 1, -1 for my image. B is at 4, -2. And C is at 2, -3. 2, -3. So once again, the idea is what changed? Got my A there. What changed? And that, of course, is with regard to X and Y. What changed? What changed between X and Y? Now, on your notes, this rule for the notation filtered down to the top of page 29. You can just write it at the bottom if you like. You have plenty of room to do it. But looking at this, ask yourself, what is the rule? What is the change? What moved? If you come up with the fact that it became, well, what did it become? Think about it. Those of you that said y and a -x, you are on the right path. If you look up here between the pre-image and the image, it's a 1, 1. And then it's a 1, -1. I can't really tell much there other than I added a negative. But looking at points B and C, which is 2, 4, and 3, 2, you can really see the difference. On the pre-image of point B, it's a 2, 4, and it becomes 4, -2. Point C was 3, 2, and then C prime, or the image point, became 2, -3. All I did was switch my Y to where the X position was and put my X in the Y position and added the negative. So my rule for this, my rule is going to be a capital R Now I could write 270 degrees, or I could write negative 90. It could work for both. So I'm going to write that so you can see that. Or negative 90. We're going to do xy. And that's going to go to, the rule is going to go to y negative x. Go ahead and pause if you need to catch up. Ask any questions when you get back into class. And thank you very much for watching the video.